Okay, let's have a look here. Prove by induction that 8 is a factor of 3 power 2n minus 1. Okay, for n natural number starting at 0. So first you want to prove it for the first case, which is prove it for case n is 0. So does 8 divide into 3? Now, I wonder, is that a typo? Because it looks like it doesn't work for 0 for this exam question. Is 3 power 0 minus 1? Does 8 divide into... Oh, I guess it does, doesn't it? Yeah, because that's 1 minus 1. 8 does technically divide into 0. Very good. Okay. This is true. 8 does divide into 0 with no remainder. Okay, 2. We assume true for n equals k, i.e. 8 does divide into 3 power 2k minus 1. And then step 3 is we're required to prove case n equals k plus 1 is true, i.e. 8 divides into 3 power 2 k plus 1 minus 1. So let's try and prove that now. There's two strategies here. You could either start here and simplify it and arrive at this statement, which is true by assumption, or start with this statement, which is true by assumption, and show that this one follows from it. So basically we can either start here and try to get to here, or start here and try to get to here. I find personally sometimes easier to start with this guy and simplify it down into this guy here. So let's try and simplify this. Can we show that 8 divides into 3 power 2k plus 2 minus 1? It's nice because it's getting closer to this. 8 divides into 3 squared times 3 power 2k minus 1. Getting closer. 8 does it divide into 3 squared is 9. 9 times 3 power 2k minus 1. It'd be great to turn this 9 into an 8. So does 8 divide into 8 minus 1 times 3 power 2k minus 1? Does 8 divide into, let's expand this, 8, why did I say minus 1? Sorry, I'm a bit tired. 9 is 8 plus 1, minus 1. 8 times 3 power 2k, 8 times that, and then times 1, which will just be 3 power 2k minus 1. So this is true, obviously. 8 will divide into anything that's a multiple of 8. You know, it doesn't really matter what integer number you get here. Whatever you get, you times it by 8, and so therefore it's a multiple of 8. So obviously 8 divides into this first piece, and 8 also divides into the second piece from our assumption in 2. So finally, step 4. So if you combine 1 and 2 and 3, these 3 results, that means it's true for n equals 0, the first case, and then 2 and 3 together imply it's the second case, or the next case is true. And if 1 is true, then 2 and 3 together imply it's true for 2, and so on. So there you go. We've proven that 8 is always a factor. That means that 8 divides into this term where n is a natural number including 0. Yeah, so that's not too bad.